Great. So, hi, I'm Sebastian Bernstein. I'm going to present MongoDB in the Wolfram language. So the first question is, so we've just seen how to deal with SQL databases. So Database Link was designed around an idea that you want to have a generic interface to any sort of SQL database. So it can use Postgres, it can use MySQL, anything of the sort. So MongoDB Link and the integration with MongoDB is a very different philosophy. It's that here's a database, MongoDB, and we're going to make some functionality that is completely specific to MongoDB. So the design, everything is built around how MongoDB works. It's not generic to other databases. And we'll see some reasons why this is very nice a bit later. So the first question is, what is MongoDB? And first of all, it's an open source database. So you can see the source code over there. You can read a comparison later on if you want against MySQL, which is probably the most popular SQL database. And I'm just going to time myself properly. So, okay, I've got 10 minutes. So, okay, so the main thing with this is it's a NoSQL document store. That's its main sort of function. And what that means is that you first of all don't have any schema. So for SQL, you have to define exactly what your tables look like. And if you have changes to those tables, so for example, suppose your data has a new field that wasn't there before, then you have to do schema migration, which is annoying and painful. So it's a much more flexible data model than what SQL is. But you can also opt into schema if you really want to. And that can be useful, for example, to make sure that data that comes in is of a certain form. And one thing I should also mention is that databases have sort of converged, both SQL databases and NoSQL databases, to a very similar sort of database. And what I mean by that is that something like MongoDB has picked up a lot of features that are traditionally in SQL. So things like joins and ACID transactions was in the recent version of Mongo. And SQL databases like Postgres and MySQL have got some form of document database where you can basically just say, here's a JSON document or a piece of JSON and just store that in the database. But that probably won't be exposable by Database Link. I'm not sure about that. Okay, so it also has other things. So for example, it has support for geospatial data. So for example, if you want to do geospatial queries, like finding out, what geographical points are closer to other points, and also graph database functionality. So there's a whole bunch of efficient graph lookup sort of stuff. And the philosophy that Mongo is sort of trying to work towards is that you don't need many databases. You don't need a graph database plus a SQL database plus a document store. You can sort of do everything with just one database. And it's also by far the most popular NoSQL database. So this is a ranking of databases by popularity, and yeah, it's by far the biggest and most used NoSQL database. Okay, so now that you have some rough idea of what we're talking about, what I want to show is, first of all, so the interface to MongoDB in the Wolfram language is this experimental feature called MongoLink. So MongoLink is a package in Mathematica, or Wolfram language. It was new in 11.3, so if you have 11.3, you can have a look and play with it. By experimental, it means that it could still change a little bit. We haven't completely finalized the design. It's also actually open source, so you can go to our GitHub page and actually see it. And you can make requests for functionality, or even make pull requests for functionality that's missing that you want to see. And myself, I'm actually part of the machine learning group at Wolfram Research, and we use this internally for managing massive data sets for machine learning, where you have often terabyte scale data, and we found MongoDB to be a very good fit for that. And also one thing that's quite different from MongoDB compared to the database link stuff is that everything is written using the C driver, using library link. So there's no JLink overhead, for example. So every call that you make to JLink costs, I think, like 10 milliseconds or 50 milliseconds or something. So it was designed to be super efficient and limited amounts of overhead. And it also has one of the other features is that it's very similar, the design, to other MongoDB language drivers. So for example, if you've used PyMongo, you'll know pretty much exactly what to do with this one. And of course, there's going to be, there's a longer tutorial that you can see for more information about all this stuff. So this basically will be a very quick overview of the functionality, and I can't really dive into detail too much. Okay, so let's actually just get an exact example of what we're talking about here. So let's say we've got this data. So this is a list of associations, and these associations have nesting in them. So we can actually visualize this as a data set, and we can see there's item, quantity, and these are all values, and size has nesting inside it. Now, in SQL, you can't represent this very cleanly. You have to flatten this out somehow. But MongoDB has complete support for any sort of nested data, and it can represent that in the database. And also one thing you might notice is that we have things like the date objects. So these are date objects. Current date just evaluates to a data object. And there's a whole bunch of supported types that we have natively in MongoLink. So things like associations, byte arrays, date objects, infinity, true, false values, etc., etc. Okay, so let's actually have a look at an example. So what I'm going to do is I'm running a MongoDB database on my local machine, and it's very easy to install it and run it if you want yourself. And there's some instructions on this link. If you want to run, have a database on the cloud, there's a hosted database service called Mongo Atlas, and I think there's some free tiers for people that don't want to pay for the expensive versions. So now that it's running in the background, I can connect to it, and the simple connection is with this. Cool, I've got a connection. So obviously, in this case, I can specify all the SSL options and all the authentication options if I need to do that. But if it's running locally, I can just run this, and it will find it. And I can query it. I can say, let me get all the database names that are inside this database. So a database in MongoDB is the same thing as a SQL database. So what we're going to do is we're going to make a new one called webinar demo. And this brings us to the next thing. So a database is sort of a big structure that holds all the data. And each database has a list of collections. And a collection is basically the same as a Wolfram Language dataset or a SQL table. So we can see now that there's actually no collections inside here yet. And it'll only be created once we actually insert some documents into this thing or some data into it. So how we do this is we just say, okay, let's call this thing test collection. We can say this is now a Mongo collection called test collection in the database of webinar demo. And we can insert the data that we had earlier into this collection. Let's run that, and it will tell me, oh, 3 documents were inserted. Okay, and it's also acknowledged that it's actually gotten to the database. So that's as simple as the insertion was. Nothing complicated whatsoever. And the insertion is basically you can either insert, so they're called documents, and a document is basically a SQL row or it's a Wolfram Language association. And with insert, you can either give a single document, which is a single association, or you can give a list of documents, a list of associations, which is also the same as a Wolfram Language dataset. Okay, so that's it. That's all I did. I inserted it. It told me that it worked. And the next thing is you want to actually get the data out, right? So the concept here is very similar again to the iterators or to result sets in database link. So I just simply say Mongo collection find, and it gives me back a cursor. And from cursors, we can read data. So we can say read from that cursor, and it gives me back some data. And the nesting is here, everything is still there. And the date, it converted it nicely to a data object. So there's no need to use, there's no special Mongo date object or something that you have to convert later on. All the data types come back, you can convert, they can convert it and they come back correctly as the types that you used. Okay, so one weird thing that you might notice is that it has this new field. This wasn't there before. So one thing with a lot of NoSQL databases is that they're sometimes called key value stores. What that means is that there's a unique key for every document that you insert. So that means that I can reference this particular document in my collection. And if there's not a unique field like this, then how can I actually find this document again? And what it does is that if you don't specify the special field called ID, and every document must have that, it'll just automatically insert it to be this bzone object ID. And that you can run normal on that if you want, and it'll show, it basically is, it's a hash of a bunch of information. So things like when you created the document, what machine created it and whatnot. Okay, but this is it. It's as simple as that. And if you want to get the remaining documents, instead of read, you can say read list. And read list will give you back all the other documents that you have. And if you try and read more from this thing, it doesn't return anything because now the cursor is exhausted. So it's a stateful object that you can read from. Okay, so reading is as simple as that. Now, databases without being able to query or make queries is pretty useless. So I just want to show you quickly 2 examples of running queries. So just to remind you what our data set looked like. And one thing that you might have noticed as well is that we inserted this data set and we didn't actually have a date object for the first, for the last one, for postcard. And this shows one of the things you can do with this. You don't have, compared to SQL, you basically, you have a schema and you're forced to insert things based on that schema. But for Mongo, I wasn't forced to insert this at all. So even if this is missing or if there's some other field that this postcard item has, it can easily be represented and inserted into the database. There's no restriction on saying this is not allowed. Okay, so the most simple way of doing finds or queries is something like this. So the query itself is an association. So you say, I want item, which is this guy here, item, to have the value of postcard. And if I do that, I get back the guy with postcard. And you can also do other things, like for example, you want to say, let me find all the documents whose height is greater than 9, let's say. So Mongo has a whole bunch of special operators that start with $, that basically allow you to do sort of operational queries. In this case, this is the greater than operator. So I can say size and then dot, which indicates that there's a nesting. H goes to that, and it will find me all the documents that have a height greater than 9. Now, this language is very rich, and it's also quite convenient to manipulate programmatically because they're just associations. They're not some string that's, some SQL string that you have to manipulate. They're just pure associations. So they're easy to construct, easy to add values, etc. And that's one of the sort of main design philosophies of MongoDB, is that it should be easy to programmatically query these things rather than having to write strings, which is nice to do by hand, but it's not nice to do if you're doing it programmatically. Okay, so queries, yeah, and you can read a lot more about queries. There's a very rich query language, very similar to SQL. The last thing I'll mention is that there's also a very sophisticated data aggregation pipeline. So what this allows you to do is to basically say, let me do data analysis steps that the database itself has to do, and it can optimize that operation massively, and you don't have to do that on your computer. And the reason you want to do that is that suppose I want to find the average of a terabyte of data. I don't want to do that on my computer. I want the database to do that for me. So I can set up, there's a whole bunch of documentation on this, but I can set up very, very complicated pipelines that the database should run on my data to do things like averaging or sorting or anything of the sort. And it has all kinds of out-of-core algorithms to deal with that stuff. And here's just a very, very simple example. There's a sample operator that basically just gets a random sample of the of the collection. So it takes the collection, it samples and says, give me back 2 samples of the data. And this is a random sample. And also just for convenience, we've got something random sample of collection and then 2, and that gives you back something very similar. So that's basically as much time as I've got. There's other topics like how to update documents, how to delete them, how to get statistics about the database operations. And the last thing that I just want to leave you with is that there's a very, very nice graphical user interface for MongoDB called Compass, which is a very, very slick sort of external program that you can play and write queries with and whatnot. Okay, great. I think that's basically as much time as I've got. So thank you.